Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Use the image showing the paper title and author's script. Imagine if AI agents could learn skills the way humans do, not just solving tasks once, but remembering strategies, improving them, and reusing them later. But today's AI agents often suffer from one big problem. They keep reinventing the wheel. Every new task becomes a new attempt, even if the agent has solved something similar before. That's exactly the problem addressed in the research paper. SkillNet create, evaluate, and connect AI skills. This work was led by researchers such as Yuan Liang and Ruobin Zhong from Zhejiang University, along with collaborators from Alibaba, Tencent, and other institutions. Their goal? To build a massive infrastructure where AI skills can be created, evaluated, organized, and reused at scale. Let's step back for a moment. Modern AI agents can already call APIs, use tools, perform multi step tasks, but there's a hidden limitation. They lack long term skill accumulation. In other words, even if an agent learns how to perform a task once, it often cannot store that knowledge as a reusable capability. The paper explains this through the evolution of AI systems. First came the symbolic AI era, which relied on rigid logical rules. Then the deep learning era, where knowledge was stored in huge neural networks. And now we are entering the agent era. In this new era, intelligence should be built from modular, reusable skills rather than hidden parameters. SkillNet proposes a framework to make that possible. So, what exactly is a skill in SkillNet? Think of a skill as a self contained capability package for an AI agent. Each skill includes instructions, metadata, optional code, or resources. And every skill lives inside a folder containing a file called skill.md, which describes how the skill works. Agents use skills through a three-step process. First, discovery. The agent scans metadata to find relevant skills. Second, activation. It loads the full instructions. Third, execution. It performs the steps and optionally runs code. This makes skills portable, reusable, and version controlled, allowing agents to share knowledge across tasks and environments. SkillNet doesn't just store skills randomly, it organizes them into a structured knowledge network. This architecture contains three layers. First, the skill taxonomy. This categorizes skills into domains like development, science, research, and testing. Second, the skill relation graph. This layer connects skills using relationships such as similar to, depend on, compose with, belong to. This allows AI agents to reason about how skills relate to each other. Finally, the skill package library. This layer groups skills into deployable packages that agents can easily install and use. Together, these layers form a large-scale skill ecosystem for AI agents. SkillNet also introduces an automated system for creating and evaluating skills. Skills can be generated from multiple sources: user interaction logs, GitHub repositories, documents like PDFs or PowerPoint, direct prompts from users. But not every generated skill is trustworthy. So SkillNet evaluates them using five key dimensions: one, safety; two, completeness; three, executability; four, maintainability; five, cost awareness. These evaluations ensure that only high quality skills enter the repository. In fact, the platform already contains over 200,000 candidate skills with more than 150,000 curated high quality ones. But does SkillNet actually improve AI performance? The researchers tested it in three simulated environments: Elf World, a household task environment; Web Shop, online shopping decision tasks; Science World, a virtual science lab. When agents use SkillNet, average rewards improved by about 40%, and task execution steps were reduced by around 30%. This means agents not only perform better, they also solve problems faster and more efficiently. SkillNet also enables fascinating real world applications. For example, in scientific research, an AI agent could clean biological data, analyze genetic pathways, validate findings, and automatically generate research reports. In software engineering, SkillNet can help AI agents analyze large code bases, refactor complex components, generate tests, and update documentation. In other words, SkillNet turns fragmented AI capabilities into structured workflows. SkillNet represents a major step towards self-improving AI systems. Instead of solving tasks one at a time, agents can now accumulate skills, share knowledge, and continuously evolve. And this idea might eventually power the future vision of AI-driven labs, companies, and autonomous research teams. The era of skill-based AI intelligence has just begun. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.